Hi. Well, it's been a long time since I've seen y'all. Sure have missed you. I hope you've had a good break. It's just been crazy how long we've been gone. I see as I look in the mirror here and this reflecting, I can see my glasses reflecting everything back. So y'all just have to deal with that. Kind of not real tech savvy here, so it's just kind of hit and miss. We're going to go ahead and I'm going to talk to you about a lesson that we're going to do. And this one lesson will be pretty much review. It's on properties of water. We've talked about that different states of matter, and we've talked about the water. And so this lesson that'll start next week is the physical properties of water. And I'm going to go ahead and kind of show you this, but I'm going to read it to you so that way if there's something that you're not really quite sure about. So I'm going to hold it up where you can see it, but hopefully you'll have yours to follow along too. This is called the physical properties of water. At the top, it gives us our vocabulary, and it's specific heat, coolant, and kinetic energy. And these are terms y'all probably have heard before. We've talked about them. Water is the only natural substance that's found in all three states: solid, liquid, and gas. And we know the solid is ice, and the gas is like steam. It boils at 212 degrees Fahrenheit, and it freezes at 32 degrees Fahrenheit. Water has a specific heat index. So there's one of those vocabulary words. Specific heat is the amount of energy required to change the temperature of a substance. Water can absorb a lot of heat before it begins to get hot, which is why sand at the beach always feels hotter than the ocean water. Land absorbs heat faster than water. Water's high specific heat index makes it valuable, especially to manufacturing companies. It is used as a coolant because it can absorb a lot of heat before it begins to get hot. Water can move overheated elements in a factory, absorbing the heat from machines in a car. Water is a coolant in the radiator that absorbs heat put out by the engine. So we know how hot the motors get, and we have to add the coolant to it to help keep it cooled off, or it would just overheat. When water molecules make a change in the phase or state, their molecules rearrange themselves into different patterns in the liquid phase. Water molecules are closer together with no regular arrangement. The particles of a liquid vibrate up and move about and slide past each other. The solid has a tightly packed particles that are usually in a regular pattern. There is very little vibration or movement of particles of a solid. In the gaseous state, water molecules are widely spread apart and very active with no regular arrangement. Generally, as the temperature rises, matter moves to a more active state. This movement of molecules is called kinetic energy, and we've talked about kinetic energy before because it's either potential, can move, or if it's moving, it's kinetic. Most substances are in the densest in their solid form. However, water is different. Solid water or ice floats on top of the water. Why is this? In order to float on water, a substance must be less dense than water. When ice is formed, the water molecules are tightly packed together, preventing them from changing shape. Ice has a regular pattern with molecules held tightly, rigidly apart by their bonds. This causes the ice to form crystalline lattice structure. These crystals have many open surfaces throughout their structures, making ice less dense than liquid water. And then they've got a little table down here at the bottom of it, and it says gas, liquid, and solid, and then it talks about the particle arrangement, shape, kinetic energy, or how it moves, fluid, and volume. And then on the next page, there's the question go with it, and you should be able to get everything from this sheet here. Why does water's specific heat make it a good coolant for car radiators? And that's one of the paragraphs in here. Which state of matter has the most kinetic energy, so it means the most movement, or which has the least movement? How does heat affect water in its state of matter? So what does heat do to it? What is the picture below showing? And so it's got three little pictures, and it's got an arrow moving up, and so they want to know what it's showing. Let me see if I can find that one. Okay, so you can see the little pictures and the arrows going up. And then it's got the vocabulary, the words they want you to define. Now, in another video, I'm going to attach some links. I'm going to have a little video for you to watch. And then I'm going to try and attach a link that has like an animation that shows this. It's kind of fun. I don't think we've done that yet this year, so you can look at it. So hopefully you'll have access to that. This is really a strange way to try to teach and talk to y'all about this, and so hopefully I'll get a little more comfortable with it as we go along. And I know this is kind of boring right now, me sitting here just in front of this blank wall, but I'll try to make it a little snappier. I do have picked up a few little fun things to kind of play with, but we'll do that later. So keep watching. Hopefully I'll have more videos before long and they'll be better. I sure miss you guys. I miss my group hugs and all my little sweeties. So I've been thinking about you a lot. And so hopefully we'll see each other soon. I'll move this so we can see my eyes. But anyway, y'all take care, and I will post another video soon. Bye-bye.